we've made a bank account class. We've made our print and equals method. Feeling good. Here's what I want to do. I want to imagine I'm a bank, right? I want to have a ton of different bank accounts, but I don't only have bank accounts. I have savings accounts also. A savings account is a bank account. You guys read about is a relationships, right? A savings account is a bank account, but it's going to have additional things also, like an interest rate, and maybe we limit the number of times they can withdraw, right? So I'm going to, in the same folder, create a new class called savings account. Nothing special about the way I'm defining this, no main method. I've got a class savings account here. So savings account is a bank account. We'll get to how we actually extend it. This is where inheritance comes in just a second. But for now, let's kind of move away from that and just think about, if I were a bank, what are all the things that we would want a savings account to have? I again would want them to have an account number, right? I again would want them to have a balance, right? And then I also want them to have an interest rate, right? You get interest on your savings. Good? We could continue on, but they've got these same things that a bank account has, plus one more new one. So even though this is a small example, hopefully you can see that if I were to be writing a large program, I don't want to have to define the same things over and over again. I want a savings account to inherit all of the stuff that a bank account already has, and then I want to also add new stuff to it. With me? So that's the whole idea of inheritance. In order to make this happen, if we want savings account to inherit from bank account, we write the word extends up here, and then the class that it extends from. So savings account extends bank account. You can always interpret extends as inherits from savings account or bank account, or savings account is a bank account. Good? Now let's pause and make sure that you feel okay with the idea of inheritance. If I were to create, maybe I work for a vet office and I create a class called pet, and I keep all these different things about pet. Then I want to create a class called dog, and I want it to extend pet. I want it to have a name and a weight and all the things that all pets have, but then additionally put some things in there that are unique to dogs. Then I could also extend pet again to cat, and then extend it to bird, right? So you've got this kind of template that we've been making the whole time, and then you've got more specific versions of those templates. Good? Does that make sense? Okay, so now I don't have to declare account number and balance again. So account number and balance are inherited from bank account. They're already here. We don't have to do anything with them again. All methods are inherited from bank account. With me? We have, it's like imagining that all of this stuff is already here. We don't have to rewrite it. Good? Now there's one caveat to what I just told you. When savings account extends bank account, just by adding these lines, everything is inherited. You can imagine all the code being in here. If I create a savings account object, I can use the print method. I can do all those kinds of things. But the only thing that I need to change is it inherits all of these public fields, and it doesn't inherit private fields in the way that we would like. So what we want to do is, if bank account has some fields that we want to pass down to our children, right? We want our children to inherit. We want to change these. We still don't want them public and open for the world, but we want to say, yeah, our children can have them too, right? there's a new word for this, and it's called protected. So I'm not making my static variable protected, just the instance variables. So far, so good? So account number and balance are now no longer private. They're protected. You guys read about this, right? So this means that it's like still being private, but any class that extends that class also has them. So now this statement is true, that account number and balance are inherited. Now some of you might be wondering why I didn't make this static one protected. The reason kind of comes down to the idea of the static variable belongs to the class, right? So I don't want different objects of different types to be able to use it and change it. So static variables by default are pretty much left private. So it would be a really bad, it would work, but it would be a bad programming habit to make this protected. So it belongs to the bank account class. However, we still have these public methods where we can interact with it. Okay, don't think too much about that one. Just know that we don't change static variables to protected. Okay, so now we have all of this code here that we can use and play with. But if I were to go create a new savings account object, I want it to print other things. I want to add things onto it, right? So first of all, I have nothing defined in this file. I want to go over to my tester class, and I want to create a savings account class, or object. Savings account, my savings equals new savings account. And then I want to, just for fun, call the print method to see if it works. My savings.print. Now the first thing you'll notice is that if all of your files are saved, it's not getting mad at you, even though we don't have a method named print defined in here. But again, because we extended it, you can imagine all of the code from bank account being accessible to savings account. So that's a pretty cool thing, right? We didn't have to redefine that. So if I run this, you can see that these are my first two bank account objects, and this is my savings account object. Account number got set to 1002, and balance got set to 200. Here's my question for you. The code that set account number and balance, where is that written? It's written in bank account, and more specifically in the constructor, right? Which means that even though I didn't define a constructor here, I don't have my default constructor. I can put it in here, but it would look like this, public savings account, right? And actually, we've made classes before where we left out the constructor, and it works fine, right? But what it does behind the scenes is there's a default constructor behind the scenes, and what it does is it calls the bank account default constructor inside of here. So that anytime you create a new savings account object, it's going to also create, because it's of type bank account, it's going to also run this code implicitly no matter what. So that's pretty cool too. If this is going over our heads, let's back up a little bit. Savings account is a bank account. So when I create a new savings account object, all the stuff that I would do to create a bank account is still done. That's the idea. It's still done behind the scenes, but we never see the code for it. This is what the code actually looks like. Super dot, I think it's this, super. This is how it's actually written in Java behind the scenes, so that when I create a new savings account object, it calls my super class, or my parent class's constructor, default constructor. Now we don't have to put this in here, but I just wanted to expose you to the idea of you can call your super class's methods within this class. Okay, we'll take it out. I know it seems scary. So far, so good? Now, I can use the equals method. I can use my set, my get methods. I have a savings account, and even though there's nothing defined in this, I am basically just creating another bank account at this point. So in order to use the inheritance relationship and make sense that I made a new class, let's add on to it. So this is right now just another bank account, but we want to say that a savings account also has an interest rate. So let's create a private double interest rate. And then we can create a accessor and mutator, generate getter and setter for interest rate. Done. And then all the other bank account stuff is in here too. Good? Now, it's nice to make constructors, right? So let's go ahead and make a constructor for savings account. Public savings account, we'll make the default constructor. And I'm making this because we know it's good practice to initialize our variables, right? So pick some value. I'll say that the interest rate by default is 1%. It's a very low interest rate. So far, so good? Nothing scary. You can just imagine that this is the bank account class, but I've added these methods in. Yeah? Okay. Now if I go and run this code again, where I create a new savings account, right? It's going to call my default constructor that I defined. And even though I didn't put a call in here to the superclasses constructor, it still calls it implicitly right here. Implicitly calls the superclass, which in this case is bank account constructor. So that means that before we ever set interest rate, we come over here, we set balance to 200, account number to our available account number, and increment the available account number. So all of that happens, and we're additionally setting our interest rate to some default variable. Now, I don't have to put this line of comment in here. You don't have to do anything different. You just have to understand that that code still runs. So if I save this and run it, nothing's going to look different here because my print method still just prints the account number and the balance. I could also print system.out.println my savings dot get interest rate. Again, because I made that method get interest rate that returns it here, and run it, and it prints the interest rate also. I'm going to pause for a second and ask you some questions. This line of code where I'm printing out the interest rate, could I change the object my savings to account 1? Could I say account 1.get interest rate? No. Why not? Account 1 is of type bank account. So it has all of these things that a bank account has, right? Savings account is a savings account. So it has all of these things that we define plus those public and protected members of bank account, right? So it's an enhanced bank account, an extended, that keyword, extended bank account, right? Okay, so if I try to do this, account 1.get interest rate, that does not work, right? It's going to tell me bank account. The method get interest rate is undefined for the type bank account. Savings account object can use it. Good? Okay, now when I printed bank account, it still printed, when I printed my savings, I like that it prints the account number and the balance, but I also want it to print my interest rate. I've got more things I want to print, right? What I can't do is go to bank account and add in that it prints the interest rate because there's no interest rate. Bank accounts don't have interest rates. Following me? What I can do is override the method. So even though I already have a print method, I'm going to override the method. You don't have to use this at override, but it's good habit to do it. And basically you can just copy and paste like, hey, the bank account class has a print method and I want to override this print method. Following me? So I could just copy and paste this. What this line of code does, if I can omit this and it's still going to work, what having this in there does, the at override, is you're telling Eclipse, I'm going to override a method. And so if I accidentally put a different return type, like maybe I forgot and thought that the print method returned a string, it's going to say, oh, there's not a method in bank account that returns a string. So it's going to make sure that you're actually overriding the same exact method. Good? This is not to be confused with overloading. There's nothing different about this method. This is overriding it. Anytime a savings account object calls print, I want to use this one instead of that one, is what it's saying. Now, if I told you that I wanted your bank account, your savings account, to print account number, balance, and then interest rate plus the interest rate, you would probably be tempted to go copy and paste that code and then add a print line, right? We can do that. It's not the right way. We can do that. It'll work. I can go copy and paste this code so it prints bank account stuff like this and then prints extra savings account stuff. System.out.println. The only extra thing in my little version is an interest rate. This works. We can leave this. I'll show you a more elegant way in a second, but let's make sure this works once you've finished it. So first of all, this is the way students typically do this. If I say, okay, now make your savings account print method, print those things and a new thing, they go copy and paste it and add a line of code, right? And there's nothing wrong with that. We're going to go save this file. I haven't changed my method call. I'm just calling print. But now since we have a new print method in savings account, as long as we've saved this file, if I run this, you can see that it printed account number, balance, and interest rate. This is my extra print line down here that I'll comment out for next time. Good? Now we know that anytime we're tempted to copy and paste code to repeat something, probably a better way to do this, right? So this works fine because there were only 2 lines of code that I had to copy and paste, but what if our print method printed out like 50 things? We could copy and paste that code, but that introduces a lot of room for errors. Also, let's say that something changes in our software. We have a software update a month down the road. We've got to change the code in 2 different places. You can see how that's an issue in like real software. We want to never copy and paste code. If we have something written like this, then we just want to use it. We want to say, hey, print, hey, use this code that we already have written by calling this method, right? And then print my extra line. Does that make sense? So because this code is exactly the same, all I want to do is call the print method. Following me? Except this is calling its own print method. This is going to be stuck in some weird cycle of calling itself. We don't want to call this print method. We want to call the print method of our superclass. Now, again, you could have left your code the other way, but this is a more elegant way to write this. So this is going to call the print method of bank account. So this code will execute. Then we'll actually print out the interest rate right after that. Good? Kind of a cool little hack there. Okay, and we'll run it, make sure it still works. Good? Okay, what if I asked you to write an equals method? Well, public Boolean equals, there's already an equals method in the savings account, or in the bank account class, and it accepted a bank account object. What type should this equals method accept? A savings account. Now, in this case, I don't want to use @override, and the reason is this does not match exactly this method, right? Bank account versus savings account, there's a difference there. So this actually is not considered overriding the method. This is more of overloading, right? If you can imagine these being declared in the same class, one accepts a savings account, one accepts a bank account, so they're overloaded to different parameters. So I'm going to leave out the @override. Anytime it matches exactly, you can put this in there, but it's optional. But just like we did before, we want to make sure, so we want to return true if interest rate and account num are the same. I could do balance also, but these are my criteria. So we already have a method that checks if the account numbers are the same, right? It's the equals method. So we already have an equals method. I can pass this in there, this savings account. I'll call my superclasses equals method. Let me pause so we can talk about this. So just like I called superclasses print method here, I'm calling the superclasses equals method. And the superclasses equals method has an object that calls it, right? So whenever I call my equals method, just like I haven't called this one yet, but it'll look just like this. I could have to call it with a savings account over here and a savings account in here, right? So the savings account that called it, I have access to in here, and if I call my superclasses equals method, then it also would be the calling method. So it's going to grab its account number, the calling object's account number. And because you might say, well, this is a bank account, and we're trying to pass in a savings account. Type mismatch, right? This works. Because savings account, here, follow me with this. Because savings account is a bank account, we can pass it in. It will fly as a bank account. We can pass it in as a bank account. This is the idea of polymorphism. The children type, the inherited types like savings account, can be passed up into the bigger parent types. We're going to keep practicing with this, but this is the idea. So I can pass in here a savings account object into somewhere where it expects a bank account. And I couldn't go the other way. I couldn't hand a bank account into something that accepted just a savings account. It's not going to fit. So the rule of thumb is, since savings account is a bank account, it fits in bank accounts. Good? So it fits. Okay. This is one way to do it. You could copy and paste this code, right? Make sure that the account numbers are the same. That would work too. But I can also call the superclasses equals method. Call the superclasses equals method. So if the superclasses equals method returns true and interest rate equals, remember, this is going to grab the interest rate for the calling object. So if the calling object's interest rate equals the passed in object's interest rate, then return true, else return false. So this is doing all the work from the superclass. Again, you could copy and paste the code here, but I'm going to do it the nicer way. And then checking that the interest rates are the same. Now we know we shouldn't use equals with doubles, right? So I would actually want to design some math here to make sure that they're within a certain range. So I'm going to say math.absolute value of my interest rate, one interest rate minus the other interest rate, and make sure that it's less than 0.01. So I'm making sure the difference, if I subtract the two interest rates, is within 0.01. This is right out of your textbook, how to check ranges. Good? Hey, this method, we called it with the name of the class. So what kind of method does this have to be? We didn't call it with an object. We didn't have to say math, my math equals new math, and then call it with the name of the object. So what do we know about this method? Static. Static meaning that method belongs to the class. We didn't have to create an object of that class to use it. Just a little side note. Okay. So now I can run it. I'll create another savings account. Your savings, I have my savings and your savings equals new savings account. And then I'm going to copy this, your savings.print, and then print out equals my savings dot equals your savings. The order of these two doesn't matter. Save it, run it. Let's look at what printed. So my first two bank accounts printed, right? That's still from up here. It says they're not the same. The equals method for these two bank accounts says false, and it was because the account numbers are different, right? Then I printed both my savings account and your savings account. The account numbers are different. The balance and the interest rate are the same. So our equals method said false. And again, it's because the account numbers are different. If I want to test this where I force it to be true just to see if it works, I'm going to set your savings dot account number. Nope, dot. Can't access account number in here. Set account number. Is that a method? It's undefined. Did I? Okay. It still says it's wrong. Okay, it just wants me to put the argument in. Your savings.set account number to my savings.get account number. That way I make sure they're the same. I could have hard-coded values in. But I'm going to do that. So I grab one's account number and make sure the other sets it to the same thing. Now if I run it, both of these have the account number 1002, balance, interest rate are the same, and it returns true.